Hi there. So in this video, I'm going to talk about how would you algorithmically solve the problem of traversing a tree in a zigzag order. So let's first look at an example. So here is an example of a binary tree, and the zigzag traversal would first go to 2, then it would do a left to right traversal, so 3, 4, and then right to left traversal, that is 7, 6, 5. Sorry, it should be 7 over here, so that is 7, 6, 5. Now, let's look at how do we do a level order traversal. Let's forget about zigzag order and let's try to look at the algorithm for doing a level order traversal. And then we would borrow some ideas from here and then we would try to do a zigzag traversal. So the way we do that is we use a data structure called queue. And we start with the root node in the queue. And we loop till the queue is empty. So basically we dequeue the queue and then in queue its children, first the left child and then the right child, and then we print out the stop element. Now the time complexity for this is order n, since you're looping over each of the nodes, so that is order n time, and then the space is also order n. Now let's try to come up with some ideas for zigzag traversal by keeping the previous algorithm and data structure in mind. So we would like to use the queue approach. Now, the zigzag traversal, one of the key things in zigzag traversal is that when you're at a given level, which is like even or odd, then you need to decide based on whether the level is even or odd, whether you should be traversing left or you should be traversing right. So we can think of an augmented data structure, which would not just store the node value, but it would also store the node level. And now, if the current level of the node is odd, then we keep the traversal as it is. And if the current node level is even, then we would need to basically reverse the order in which we are printing out the elements. So what we would do in order to reverse this order is we would push these elements onto a stack, and on the next level, we would empty out the stack. And that would print out that level's elements in a reverse order. So let's look at the overall algorithm. So you initialize the queue with the root element and a level 0, and you loop till the queue is empty. You dequeue the queue and you enqueue the left child and then the right child. This is similar to the level order traversal that we have. And if the current level is odd, then what you do is you empty out the stack that you had previously and print out. And after emptying out the stack, you print out the current top element. If the current level is even, then you push the top element to the stack. And in the end, after the loop is done, your stack might not be empty. So you just empty out the stack and then print out the elements in last in, first out order. So let's try to understand this with an example that would be best. So for the tree that we had over here, we would start with a queue with the values 2 and the level 0. And your stack would be initially empty. Now you would dequeue the queue, so your top element right now is 2 and the level is 0. And as we saw in the algorithm, if the current level is even, then push the top element onto the stack. So now our stack becomes 2. Now we dequeue the queue again, so our top element is 3 and the level is 1. Now if the level is odd, then you need to empty out the stack and print the current top level. So you empty out the stack, so you output 2. And then you print the current element, which is 3, and then the stack becomes empty. Now you dequeue 4 and 1. So when you dequeue 4, then your level is odd and your stack is already empty. So you would just print out the current element, so that is 2, 3, 4. Now when you dequeue 5 and 2, your current level is even. And if the current level is even, you push the element onto the stack. So you push 5 on top of the stack. Similarly for 7, you push it on top of the stack since the level is even. And for 6 and 7. So your stack in the end looks like 5, 6, 7, and your output is 2, 3, 4. And now your queue is empty, you break out of the loop, but your stack is not empty yet. So now you would just pop out the stack and print out the elements. So that would be 7, 6, 5. So now your zigzag traversal is basically done. So what is the time complexity of this? Again, it is order n since you're visiting each node once, and the space complexity is also order n. So hope you found this video useful, and this helps you write the code for the zigzag traversal of the tree. And if you like this video, please subscribe to the channel. Thank you.